to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze the Y-shaped pipe for its modal analysis. We will start by double-clicking on the modal module. We'll first go to Engineering Data and double-click. Here we are going to add the materials for which we are going to analyze. So we will start by using the material of CPVC. Here we'll first add the density, which is 1650 kg per meter cube. Also, we will give the value of isotropic elasticity. Young's modulus is 3.1 gigapascal, so E9, and the value of Poisson's ratio is 0.386. Next, we'll add the material of galvanized steel or galvanized iron. So let me write it as GI. I will give the density as 7850. I will give the value of isotropic elasticity. Young's modulus is 200 gigapascal, so 200 E9. Value of Poisson's ratio is 0.29. Then the next material is HDPE. The value of density is 995 kg per meter cube. Also, we will give the value of isotropic elasticity. Young's modulus is 1.5 gigapascal, so E9, and value of Poisson's ratio is 0.45. Apart from this, we will add another material, which is stainless steel. So we'll click on Engineering Data Sources. We'll go to General Materials and double click. Here we'll choose stainless steel and bookmark. Again, I'll click on Engineering Data Sources. You can see all the 4 materials have been added. I'll go to Project and Update Project. Next, I'll go to Geometry and right click. I'll import the geometry of the Y pipe. Then I'll go to Model and double click. We'll first go to Geometry, Solid. Change the material to stainless steel. I'll go to Mesh and I'll just update the mesh with whatever sizing is default. I'll go to Model and right click, Insert, Pick Support. I select face, this one, apply. Next, I'll go to Solution, right click and solve. You can see here for the 6 modes, we have 6 frequencies. I'll left click here, right click, select all. Again, right click, create mode shape results. I'll go to Solution and solve once again. We'll go to the first deformation. It is showing a deformation of 18 mm for a frequency of 54.67 Hz. You can animate and see this result. This is the maximum value of deformation. Then we go for the second deformation. Again, you can animate and see. The frequency is 56.914 Hz. Maximum deformation is 21.916 mm. Then I'll go for the third one. The maximum deformation is 16.797 mm and the frequency is 69.04 Hz. You can animate and see the pattern of its motion. Then we'll go for the fourth deformation. The highest value is 27.39 mm and the frequency is 159.93 Hz. You can animate and check this result as well. Then we'll go for the fifth deformation, whose highest value is 28.94 mm. Frequency is 183.47 Hz. And then we'll go for the last one, whose maximum deformation is 39.993 mm and frequency is 193.09 Hz. So this indicates that for this Y pipe, given this condition, if you happen to reach this frequency, you will get this amount of deformation. And these are the 6 natural frequencies of this pipe. Now we have 6 because you can check in the analysis settings, max modes to find our 6. You can increase or decrease this number as per your requirement. Now we'll change the material to CPVC and we'll solve once again. You can see here for the first mode, the maximum deformation is 40.7 mm and the frequency is 15.27 Hz. Pattern of motion will be the same for every material. So we will just see the value of deformation. Second mode, the value of deformation maximum is 47.41 mm, frequency 16.124 Hz. Third one has highest frequency of 19.211 and deformation of 36.55 mm at this value. For the fourth one, you can see how drastically the value of deformation has changed. It is 56.2 mm and here it is 45.42 Hz. For the fifth mode, maximum frequency is 51.548 Hz. Deformation is 48.909 mm. And for the last mode, maximum deformation is again 87.024 mm and frequency is 57.054 Hz. So you can see for this value of frequency, this is the amount of deformation you will get, given the material is CPVC. Now let's change this material to HDP and solve once again. We'll see for the first mode, total deformation is 51.59 mm for a frequency of 14.133 Hz. Second one, the value is 60.989 mm, frequency is 15.46 Hz. For the third one, you can see there is a decrease in value of deformation 47.629 mm for a frequency of 17.626 Hz. For the fourth one, the value of deformation is increased to 65.81 mm and the value of frequency is 43.393 Hz. For the fifth one, the value of deformation maximum is 47.96 mm, frequency is 47.921 Hz. And for the last one, there is a drastic increase in the deformation 112.76 mm for a frequency of 60.566 Hz. Now there is one more material we have which is of galvanized iron. I leave it to you to analyze for it for the given value of material properties. It will give you values similar to stainless steel because it's also a steel that we have assumed. But what is important is if you are using a CPVC or a HDPE pipe, you can see that the amount of deformation is more for a smaller value of frequency. So you should be careful when you're using this kind of a pipe because its natural frequency is quite low and the deformation is quite high for these natural frequencies. So you don't have to tap these natural frequencies, you need to avoid tapping them such that you are able to protect the pipe and it has a longer life. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.